In 1943, as the Second World War entered its most brutal and decisive phase and Europe scarred beneath years of conquest, bombing, and occupation, a realization quietly emerged within the upper circles of German intelligence that the war was no longer being decided solely on battlefields or in the minds of generals but inside factories, spreadsheets, and production schedules. And this realization crystallized in the mind of Admiral Wilhelm Canaris, the head of the WWII, a man who, unlike many in Hitler's inner circle, understood that ideology could inspire men but could not alter mathematics. And when Canaris examined reports coming from neutral observers, economic analysts, and industrial reconnaissance, he encountered a figure so staggering that it contradicted everything Nazi leadership believed about American capability. The Ford Motor Company's Willow Run aircraft plant in Michigan was approaching a production rhythm that, when averaged across shifts and days, amounted to the completion of one fully operational B-24 Liberator heavy bomber every single hour, a number so immense that even Canaris initially questioned it, recalculated it, and verified it repeatedly, because this was not simply a statistic but a strategic death sentence. And when he finally presented these findings to Adolf Hitler, carefully explaining that this was not rumor or propaganda but industrial reality derived from factory size, labor allocation, assembly line speed, and material throughput, Hitler rejected it outright, laughing at the notion that a nation he viewed as decadent and commercially obsessed could outproduce Germany's war-hardened Reich. Yet what Hitler failed to grasp was that the United States had transformed war itself into an engineering problem, and Willow Run was its most terrifying solution, because unlike traditional aircraft factories that relied on skilled craftsmen working in isolated teams, Willow Run was conceived as a machine that built machines, a production ecosystem stretching over millions of square feet where time was measured in seconds and inefficiencies were hunted down with ruthless precision. And this factory did not emerge overnight but was born from Franklin D. Roosevelt's understanding that the coming war would be won not by who fired the first shot but by who could sustain the longest output, and so even before Pearl Harbor, the American government mobilized industry on a scale unseen in human history, calling upon Henry Ford, a man whose genius lay not in aviation but in repetition, standardization, and flow, and asking him to do the unthinkable, turn one of the most complex bombers ever designed into an assembly line product, and Ford accepted not because he was a warrior but because he believed that production efficiency was a moral force that could end wars faster by overwhelming enemies beyond recovery, and what followed was an industrial miracle that German planners could neither predict nor counter. As farmland vanished beneath concrete, steel trusses rose like the skeleton of a mechanical beast, and a workforce numbering in the tens of thousands was assembled, trained, and synchronized, many of whom had never worked in factories before, including women, farmers, clerks, and immigrants, all converted into components of a living industrial organism. And the B-24 Liberator itself, with its 4 engines, long-range, massive bomb load, and complex internal systems, was considered by many aviation experts to be unsuited for mass production, yet Ford engineers dismantled the aircraft conceptually, breaking it into thousands of discrete tasks, each simplified, timed, and standardized, ensuring that no single worker needed to understand the entire plane, only their precise role in the flow. And this approach shattered traditional limits, because it allowed speed to replace craftsmanship without sacrificing functionality. And as the months passed, production curves climbed relentlessly, bottlenecks were eliminated, errors were analyzed statistically rather than emotionally, and improvements were implemented continuously, while across the Atlantic German factories struggled with shortages, allied bombing, forced labor inefficiencies, and political interference. And this contrast was the silent battlefield where the war was truly decided, because every hour Willow Run completed another bomber, another crew would be trained, another mission would be flown, and another segment of German industry would be placed under attack. And Canaris understood that this was not a question of whether Germany could shoot down these bombers but whether it could do so faster than America could replace them, and the answer was mathematically impossible. Yet Hitler, obsessed with wonder weapons, ideological purity, and personal intuition, dismissed such calculations as defeatism, surrounding himself with loyalists who reinforced his denial, and in doing so he sealed Germany's fate. because Willow Run was not merely a factory but a time engine, converting hours into aircraft and aircraft into strategic inevitability. And while speeches, flags, and propaganda continued to fill German airwaves, the real countdown to defeat was ticking in Michigan, measured not in days or months but in units per hour, proving that in modern warfare, industrial arithmetic can be more lethal than any bomb, and that the Third Reich was not defeated only by soldiers and generals but by conveyor belts, stopwatches, and a factory that never slept. While Willow Run continued to accelerate its output and transform abstract numbers into physical bombers, the consequences of this industrial surge began to ripple across the Atlantic, slowly at first and then with unstoppable momentum, as the skies over Europe filled with formations of Allied aircraft whose sheer scale rewrote the rules of air warfare. And this was the phase of the war where the Luftwaffe, once feared as an unstoppable force, began to confront a problem no amount of bravery or tactical skill could solve, because German fighter pilots were no longer engaging isolated raids or manageable waves but endless streams of bombers that seemed to regenerate faster than they could be destroyed. And this was not coincidence but calculation, because American planners, armed with Willow Run's production data, deliberately embraced a strategy of sustained pressure, knowing that losses, while painful, were acceptable if replacements arrived faster than German defenses could adapt. And this strategy placed an unbearable burden on German industry, which was already operating under the strain of Allied bombing, resource shortages, and internal inefficiencies caused by political interference and forced labor systems that lacked the motivation and skill necessary for precision manufacturing. And as 1943 progressed, the contrast between the two systems became impossible to ignore, because while American factories standardized parts and optimized processes, German factories were fragmented, competing for resources, and constantly disrupted by air raids that forced production underground or into smaller, less efficient facilities, and this fragmentation destroyed economies of scale at the exact moment when scale had become the decisive factor. And Wilhelm Canaris saw this collapse forming long before it became visible on the battlefield, because intelligence reports revealed not just aircraft numbers but pilot training statistics, fuel availability, and repair timelines, all of which pointed to the same conclusion: Germany was losing a war of replacement, not courage. And this reality struck hardest during the Allied strategic bombing campaign, when formations of B-24 Liberators, many of them born on the same assembly line at Willow Run, penetrated deep into occupied Europe to strike oil refineries, ball-bearing plants, rail junctions, and aircraft factories, targets chosen not for symbolic value but for mathematical impact, because destroying fuel production reduced flight hours, destroying transport nodes slowed repairs, and destroying component plants multiplied delays across the entire German economy. And every successful mission forced Germany to divert more fighters, more anti-aircraft guns, and more trained personnel to defense, creating a feedback loop that drained offensive capability and accelerated decline. And the Luftwaffe's response, though initially effective, carried a hidden cost, because experienced pilots were irreplaceable assets, requiring years of training, and each loss represented not just a man but thousands of training hours that could not be quickly replicated. Whereas American pilot training programs, supported by an equally massive industrial and logistical base, produced new crews at a pace that absorbed losses without collapsing morale or capability, and this imbalance became starkly visible during major air battles over Germany, where dozens of bombers might be shot down in a single day, yet within weeks those losses were replaced by new aircraft and crews, many of whom flew planes manufactured after the battle itself. A phenomenon that shattered German assumptions about attrition, because traditionally, heavy losses were expected to force enemies to pause, regroup, and negotiate, but America did not pause, it accelerated, and behind this acceleration was Willow Run's relentless output, which functioned like a reservoir constantly refilling the front lines. And inside Germany, this reality triggered panic beneath the surface of official propaganda, as engineers, factory managers, and economists recognized that no feasible reorganization could close the gap, because Germany lacked not just raw materials but time, and time was the one resource Willow Run converted most efficiently into combat power. and even attempts to copy American methods failed, because Germany's centralized political control discouraged experimentation and punished failure, whereas American industry thrived on iterative improvement, allowing mistakes to become lessons rather than liabilities, and this cultural difference manifested in production curves that diverged further each month, and by late 1943, Allied air supremacy was no longer a distant goal but an emerging fact, forcing German cities into nightly blackouts and constant repair cycles that drained civilian morale and industrial output simultaneously. And yet Hitler continued to believe that new weapons or a decisive blow could reverse the situation, ordering resources diverted to experimental projects while existing systems starved, a decision that further weakened Germany's ability to respond to the bomber threat, and Canaris, increasingly isolated and disillusioned, understood that the numbers he had presented were no longer projections but lived reality, because the war's tempo was now dictated by American factories rather than German strategies, and Willow Run's production rhythm had become a metronome setting the pace of destruction, each hour another bomber, each day another formation, each month another layer stripped from Germany's industrial core, and this was the cruel irony of industrial warfare, that defeat can arrive not with a dramatic collapse but with a gradual erosion that left no moment for heroism to alter the outcome, only the steady accumulation of disadvantage until surrender became inevitable, and as Allied commanders reviewed production charts and sortie rates, they recognized that the battle was already leaning decisively in their favor, not because the enemy lacked skill or courage, but because the arithmetic of replacement had crossed a threshold from which Germany could not recover, and in that sense, Willow Run was not merely supporting the war effort but actively shaping its trajectory, proving that the ability to produce faster than an enemy can destroy is itself a form of dominance, and by the end of 1943, this dominance was no longer theoretical, because it could be heard in the constant drone of engines over Europe, engines attached to aircraft whose serial numbers traced back to the same factory floor in Michigan, a place where time, labor, and material converged into an unstoppable force that steadily dismantled the Third Reich from the air. By 1944 the war had crossed an invisible threshold from which Germany could no longer retreat, because the cumulative weight of Allied industrial output had transformed strategic bombing from a campaign into a condition of existence, and at the center of this transformation stood Willow Run, no longer an experimental marvel but a fully matured production engine whose efficiency had been refined through thousands of incremental improvements, each one shaving minutes, reducing errors, and increasing reliability, until the factory operated with the mechanical rhythm that mirrored the certainty of a clock, and this rhythm translated directly into operational reality, because Allied air planners could now schedule missions based not on hope or reserve stockpiles but on guaranteed future output, knowing that aircraft lost this month would be replaced next month and that losses next week could be absorbed without altering strategic tempo, and this confidence reshaped decision-making at the highest levels, enabling aggressive operations such as sustained daylight bombing deep into German territory, where risk was acknowledged but accepted because replacement capacity exceeded anticipated losses, and for Germany this marked the beginning of a downward spiral that no tactical adaptation could reverse, because the Luftwaffe was forced into constant defensive engagements that exhausted pilots, aircraft, fuel, and maintenance crews at a rate unmatched by replenishment, and every adaptation in new fighter tactics, heavier anti-aircraft concentrations, dispersed production or produced diminishing returns, as each solution consumed resources that were already insufficient, and the Allied bombing of oil infrastructure in particular exposed the fragility of Germany's war economy, because fuel shortages grounded aircraft, reduced pilot training hours, and disrupted transport, creating cascading failures that spread far beyond the immediate targets, and these effects compounded over time, turning temporary setbacks into permanent losses, while in the United States, industrial feedback loops worked in the opposite direction, as lessons learned from combat were fed back into production, leading to design tweaks, improved armament layouts, better crew protection, and standardized repairs, all of which enhanced survivability and effectiveness without slowing output, and this ability to adapt at scale was something German industry could not match, constrained by ideological rigidity, bureaucratic fragmentation, and the increasing chaos of a nation under siege, and by mid-1944 the skies over Europe had become a domain dominated by Allied aircraft, not because Germany lacked fighters, but because it lacked the fuel, pilots, and maintenance capacity to sustain them, and this dominance was critical to the success of ground operations such as the Normandy invasion, where Allied forces relied on air superiority to isolate the battlefield, disrupt reinforcements, and maintain logistical momentum. And while history often celebrates the bravery of soldiers landing on beaches, the unseen prerequisite for that bravery was the industrial guarantee that air cover would not vanish due to attrition, a guarantee made possible by factories like Willow Run that ensured continuity rather than scarcity. And inside Germany, the psychological impact of this dominance was profound, as civilians endured relentless bombing, infrastructure decayed faster than it could be repaired, and confidence in eventual victory eroded, replaced by a grim acceptance that the war was being lost not in dramatic defeats but through an accumulation of disadvantages that no speech or decree could erase. And within the intelligence community, Wilhelm Canaris watched this process unfold with a sense of tragic inevitability, knowing that the truth he had presented years earlier had now manifested in full, and that Germany's fate had been sealed the moment industrial parity was lost. And this realization extended beyond aircraft, because Willow Run symbolized the broader American capacity to mobilize resources, coordinate labor, and sustain output across multiple sectors simultaneously, creating a depth of power that could absorb shocks and continue advancing, whereas Germany's system, optimized for rapid conquest rather than prolonged attrition, collapsed under sustained pressure, and as Allied bombers roamed almost unchallenged, striking transportation networks and production hubs at will, Germany's ability to maneuver forces, supply front lines, and maintain cohesion deteriorated rapidly, turning strategic setbacks into operational paralysis, and by late 1944 the war's outcome was no longer in doubt among those who understood the numbers, because the equation of production versus destruction had reached an irreversible imbalance, and even Hitler's last hopes for decisive weapons or political fractures among the Allies could not overcome the fundamental reality that Germany was being outproduced on a scale unprecedented in history. And Willow Run's contribution to this imbalance was not symbolic but quantifiable, because every bomber it produced represented a mission flown, a target struck, and a pressure applied, and when multiplied by thousands, this pressure became overwhelming, leaving Germany with no room to recover, adapt, or negotiate from a position of strength. And this stage of the war demonstrated a harsh truth about modern conflict, that once industrial dominance is established, battlefield outcomes follow with mechanical predictability, and by the time Allied forces crossed into Germany itself, the war had already been decided in factories thousands of miles away, proving that the real frontline of the Second World War was not only in Normandy, Stalingrad, or the Ardennes, but in places like Willow Run, where time, labor, and material were fused into a force that no army could resist. As the war moved into its final phase and the borders of the Third Reich collapsed inward under pressure from all directions, the full meaning of Willow Run's achievement became unmistakably clear, because by 1945 Germany was no longer fighting for a victory but for survival, struggling to delay an outcome that had already been mathematically determined years earlier. And this realization reframes the end of the war not as a sudden defeat but as the final act of a process set in motion when industrial superiority crossed a critical threshold, a threshold Willow Run helped define, and as Allied forces advanced across Europe, encountering resistance that grew weaker with every mile, the Luftwaffe that once dominated the skies was reduced to sporadic appearances, its aircraft grounded by fuel shortages, its pilots exhausted or inexperienced, and its infrastructure shattered beyond repair. And this collapse was not the result of a single catastrophic battle but of sustained pressure applied relentlessly over time, pressure made possible by the ability to replace losses faster than the enemy could respond. And this is where the true historical significance of Willow Run emerges, because it demonstrated that modern warfare is governed by systems rather than moments, by throughput rather than heroics, and by logistics rather than ideology. And while Hitler retreated into fantasies of miracle weapons and last-minute reversals, the industrial reality surrounding him rendered such hopes meaningless, because even the most advanced weapon cannot compensate for an economy that cannot sustain itself under pressure, And as Berlin fell and the war in Europe ended, the numbers told a story more damning than any battlefield report. The United States had produced nearly 300,000 aircraft during the war, with tens of thousands of heavy bombers alone, and Willow Run had become the single largest contributor to B-24 production, at its peak delivering aircraft at a rate that reshaped strategic planning itself. And this output did more than destroy factories or cities, it destroyed the enemy's ability to recover, because recovery requires time, stability, and resources, all of which were denied by constant aerial pressure, and historians later recognized that Germany's defeat was sealed long before its armies collapsed, because once industrial imbalance reached a certain scale, outcomes became inevitable, and this understanding casts Wilhelm Canaris in a tragic light, not as a failed intelligence chief but as a man who correctly diagnosed the future and was ignored, because his warning challenged the ideological foundations of the regime, which rejected the idea that numbers could outweigh willpower, and yet history proved him right, because willpower without production is finite, while production without interruption is exponential, and Willow Run embodied this principle perfectly, operating day and night, absorbing inefficiencies, training new workers, integrating feedback, and continuously increasing output even as the war demanded more. And this capacity revealed a deeper truth about democratic industrial societies, namely that their decentralized systems, though chaotic on the surface, possess an extraordinary ability to adapt, scale, and sustain effort over time, whereas authoritarian systems, though capable of rapid mobilization, often collapse under prolonged strain due to rigidity and misallocation. And this contrast explains not only Germany's defeat but the broader outcome of the war, because the Allies did not simply fight better, they endured better, and endurance in modern war is a function of industrial depth, and after the war ended, Willow Run itself became a symbol of this transformation, eventually repurposed for civilian use, its massive hulls falling silent, yet its legacy endured in the doctrines of modern military planning, which now place industrial capacity at the center of strategic assessment, recognizing that wars are won not when enemies are defeated in battle but when they are rendered incapable of sustaining resistance, and in this sense Willow Run did not just help win World War II, it redefined how wars are understood, shifting focus from singular events to systemic advantage, and this shift carries lessons far beyond 1945, because it reminds us that power in the modern world is built quietly, over time, through coordination, infrastructure, and planning, rather than through dramatic gestures or ideological conviction alone. And when we look back at Hitler's refusal to believe Canaris's report, we see not just arrogance but a fundamental misunderstanding of the age he lived in, an age where factories could determine fate as surely as armies, and the irony is that the Third Reich, obsessed with symbols of strength, failed to recognize the most powerful weapon arrayed against it, not a tank, not a bomber, but a production line. And thus the story of Willow Run is not merely a footnote in industrial history but the central chapter in the story of the 20th century, illustrating how mathematics, logistics, and human organization converge to decide the largest conflict the world has ever known, and in the end, the truth Hitler refused to believe proved unavoidable, because no regime, no matter how ruthless or determined, can outfight an enemy that turns time itself into a weapon, and Willow Run did exactly that, hour by hour, plane by plane, until the outcome was no longer a question of strategy but of inevitability, marking the moment when industrial math, once set in motion, quietly but decisively